Alright, in problem 25, I'm going to do some more graphing the way that I do not want you to graph, but this time it's to prove a better point. So what I'm going to do, I'm going to draw a table. So I'm going to have x squared plus 2, and x squared minus 2. I'm going to use my standard -3, -2, -1, 0, 1, 2, and 3. We should all know what x squared is by now. We get 9, 4, 1, 0, 1, 4, 9, which makes sense because it's going to overlap on itself at x equals 0, y equals 0, x equals 0. All right, next we're going to take that x squared and add 2. So I'm just adding 2 to everything in this column. 11, 6, 3, 2, 3, 6, and 11. In the last column, I'm taking everything in x squared and subtracting 2. So 7, 2, -1, -2, -1, 2, and 7. I'm going to graph x squared using blue. So we have this guy, this guy, this guy, this guy, this guy, and this guy, and I will do my best to graph this. Not too bad. So it's a little wiggly, but that's okay. I am going to graph x squared plus 2 in green. So we have -3, 1, 2, 3, 11, which is going to be somewhere up here. -2 and 6. -1 and 3. 0 and 2. And then it's going to do the same thing on this side. So here is our green graph. It's exactly the same, except everything is shifted up 2. Our last one, our x squared minus 2, I'm going to put in red. So we have -3, 7, -2, 2, -1, -1, 0 at -2, and then it's going to be the same on the other side. So now we have a graph that's shifted down 2. So what this tells us is if we have an x squared and we add something to it, it's going to move the graph up that many units. If we subtract something from that x squared, it's going to move the graph down that many units.